Hello, hello. Total Development Lab back again with another video. And today we will be exploring and developing a affine solution. Now, this is the second video in the series. The first one just did a discovery and analysis or an overview of the Affine Cipher. And in this video or in this episode, we will be implementing it in the language Rust. Amazing. So let's get started. So as always, let's go ahead and create our project in Rust, and we do that with the total CLI. So we do that by saying total create Rust and the name of the project. So it'll be Affine Cipher. And went ahead and created the solution or the scaffolding. We can find that we can change our directory to that Affine Cipher. And here we are. So our Rust CLI goes ahead and scaffolds our entire project. So we could go ahead and run it. Great. So let's get started. So first things first, as we know, we need to define our alphabet size, right? So let's go ahead and create a constant, name it alphabet. Size using rail case for Rust or snake case. And we define it of type integer 32 or 32-bit signed integer, and we set it equal to 26. Great. So now let's compute the greatest common divisor of two numbers. So we can do that by creating a function, calling it GCD. And then it takes in two variables. It takes in A, which is a 32-bit integer, and B, which is also a 32-bit integer, and returns a 32-bit integer like this. Perfect. Then we say, or essentially we ask if B is equal to 0, go ahead and return. So if B is equal to 0, go ahead and return A. Right? And if, or else, if so B isn't equal to 0, let's go ahead and recurse with the GCD B, passing in B as our first parameter, and then the modulus of A modulus B for our second parameter. This should give us our greatest common divisor of two numbers. This is just a clever way of doing that, right? Or if neither of these two, let's go ahead and return none. Or, excuse me, this will give us our 32-bit integer. So next function is, or the next thing we need to do is find the modular inverse of A under mod M. This essentially is needed to decrypt and we can solve this by saying function mod inverse. We're defining a function, naming it mod inverse, and it takes it, and it should expect A, which is a type I32, which is a 32-bit signed integer, and B, which is also a 32-bit signed integer, but we also want to return option of I32. And this is just an idiosyncratic way of saying our function can return nothing. And we want it to do this, so we mitigate any errors that might happen. Because we want to say if our inverse doesn't exist, we want it to return none instead of a number, right? Cool. So in order to do that, we will go ahead and write a for loop, and we say for x in range of 1 to m. And that's written in Rust like this. I or 1 dot dot m. Then we want it to then return, or we want to ask if a times the iteration or the number between, or x essentially, modulus m equals 1. If the remainder equals 1, let's return some variable x. And at the end of this for loop, if we go through our entire range and we don't find any module or modulus or remainder or number that has a remainder of 1, we then return none. Great. So next thing to do is go ahead and encrypt a message using the Affine Cipher. Great. So let's go ahead and create a function, name it encrypt. And it needs to expect a parameter message, which is a reference to the string. As well as it needs to expect another parameter a, which is a 32-bit integer, another parameter b, which is 32-bit integer, and it should return a string. Now let's get into the meat of the encrypt function. And that looks like this. So we need to we need to use the message that we get passed in from the parameter. We need to convert that string into a character array. And we need to use that map function to loop through the character array. We take every character, C, and then ask if C is alpha or is an ASCII alphabetic, then we go ahead and call or define a function named, and let's call it base equals the byte representation of a or capital or lowercase, right? So we can do this by saying if C is ASCII uppercase, go ahead and return the byte representation of the uppercase. And then else, let's go ahead and get that lowercase. Great. And that looks like that. That's our base, right? And so let's say let x equal C, or the character, as U8 minus our base. And then let's cast that to a 32-bit integer like this. And then let's say let encrypted equal a times x plus b dot the Euclid function, and then we pass in that alphabet size that we defined at the beginning of the video. Great. So that's our if the character is ASCII alphabetic, and if it is not, let's go ahead and just return the character. And at the end of this, let's go ahead and call collect. And this should be our encrypt function. And it essentially just takes non-alphabetic characters and leaves them unchanged if they are not returned as true in this map here. Great. Now, let's go ahead and decrypt a message that was encrypted with the same key A and B. Cool. Now, let's go ahead and create our function. Decrypt, it takes in the ciphertext as a string, and the keys A and B. So we can write that as so. Take cipher of type string. So as A of I32, B of I32, and it returns a string. Perfect. Just like that. Now, we need to make sure that our A or our string or our key, excuse me, is a coprime with 26 for our decryption to work. So let's go ahead and create a check at the beginning of our function, right? So let's say let A inverse equal mod inverse of A in the alphabet size, right? So A in the alphabet size. Then we also want to go ahead and expect that to mod, and let's say A is not a number if that fails. Great. So next we could go ahead and loop through our cipher or our parameter and call the character function to get that character, right? And then call the map function to loop through each of those characters as C. Then ask if C is alpha or ASCII alphabetic. And again, let that base be ASCII alphabetic, be, and then grab the uppercase version if it is ASCII uppercase, or get the byte representation of the lowercase value, like so. Next, we say let y equal C is U8 minus B, and then cast it to an integer just like that. And let's call the let's define a variable decrypted, and it should be defined as this. It should be the A inverse times the y minus b the difference between y minus b. Then we grab that rem Euclid function of the alphabet size. And then we want to return a decrypted variable as U8 plus our base, which remember is just the byte representation of the uppercase or lowercase as a character, right? And every time we touch a character in our character array, we want to return that character with this decrypted as U8 plus the base, and then cast it as a character. Great. And if the current character that we're on is not ASCII alphabetic, let's go ahead and return the character. Great. And at the end of this, let's call collect. And this should be it. So let's go ahead and create a main function so we can go ahead and test what we just created. So let's create some keys. Let's say let A equal 5. And then let B equal 8. These are just random numbers here. And let's do a sanity check. So a sanity check. So you can make sure the key, is a coprime before doing anything else. And we can do that again by saying if the GCD of A and the alphabet size doesn't equal 1, let's go ahead and panic and exit the program. Cool. Now, let's move forward from the sanity check, and let's say let the message equal hello world. And then let's say let the encrypted, or let's define the encrypted variable as the encrypted message, or we're passing in our hello world, and then we're passing in our keys. Let's let our decrypted message be that decrypted function, passing in our encrypted value right from here. And then we should be able to print the original message like so, as well as the encrypted, and as well as the decrypted. Great. Let's go ahead and run this, see if everything's working correctly. We can do this by saying total run, and let's fix any errors if there are any. We got one error here. We got a few errors here. So let's debug this together. As you can see, we have one here for X in the range of 1 to M. Looks like this. So for X in range of 1 to M. And then we perform if A times X modulo M equals 1. Yep, that looks good. Let's see if it still exists. A similar name exists locally. So what's happening here is that we use B instead of M for our parameter value. So that should fix that. And we also have an issue up here with B. Oh, they're saying that we used parameters or parentheses. Let's see if we could go ahead and just create a space here. Oh, they just want us to remove the parentheses. Okay, that's fair too. I'm learning Rust as I go as well. Great. And now we have one more error here, and that is in our encrypt function. And we're expecting an option, it looks like, but we return C instead. Okay. Let's see. Oh, I see what we did. So we forgot to return our encrypted character as U8 plus our base and cast it to a character. Let's go ahead and run this and see what happens now. Great. It looks like everything works. Let's go ahead and run it again just in case. Great. Everything works. So as you can see, we just completed and went through the Affine Cipher. Any questions, please don't hesitate to reach out, and I will see you in the next video. Thanks for watching.